Welcome students. Now in this lecture, how to compute LCM, least common multiple of two or more positive integers by using prime factorization method. In the previous video, we discussed how to find GCD, greatest common divisor, or HCF, highest common factor, for two or more. Any number of positive integers more than one, if they given to you, we can apply that fundamental theorem of arithmetic, expressing each number as prime powers, distinct prime powers. Then we have to, for finding GCD, we have to take all the common prime numbers present in the given numbers, first stage in the product form. Then for each prime number, you take the least power among all those powers finding in each number. That is the GCD one. Here what is to be done? So same procedure. Let you name them as n equal to 96, that is more than 1, and m value 196, that is also more than 1. First we need to express these two numbers as product of different prime numbers. For 96, it is very simple. It goes with 2, 4 times 2 8s. Again 2 we can divide 24 times. Again with 2 it will go 12 times. Again with 2 6 times. Again with 2 3 times. Now next prime number is 3, only one time. Stop. So therefore, how you write n? N equal to 96. Prime number 2 is available here. It appears 1, 2, 3, 4, 5 times into 3 is next prime number, appears only one time. No need to mention P1, P2, alpha 1, alpha 2, it is understood. Next, I'll take that is 196. 196. With 2, you can try 2 9s 18, 2 8 16. Again with 2, it will go 4 times, 9 times. 3 won't go. Right, 7 we can take. 5 won't go. 7 7s 49. 7 ones. That's all. So how you write 196? That is equal to 2 is a prime number. It appears 2 times into 7 is a prime number. It appears 2 times. So we expressed 196 and 96 as prime powers. Now how to compute GCD LCM here? LCM of 96 and 196. In GCD, we have to take common prime numbers in n and m, but here, what are the prime numbers you are going to see? That you have to collect. All prime numbers you must write. Simply to say, we have to take all the prime numbers. 2 is a prime number. First I write 2. 2. There you write max. That bracket. What are the powers of 2 available here? 2. There 5 into next prime number is 3 bracket, again write max. What are the powers of 3 available to here? Only one here, into next prime number is 7, same procedure, write max. I think the power of 7 is only 2 here, only here it appears power is 2. Now based on this information, we have to take 2. Max means maximum. Maximum of 2 and 5 is 5 into. Next prime is 3. Maximum of 1 is only 1. Here also maximum of 2 is only 2. So this we have to multiply and compute. 2 to the power 5, it is 32. It is 3. It is 49. Let us use calculator and compute. 32 into 3 into 49. It is 4704. 4704. You can use calculator. 4704. That is your LCM. Least common multiple. Least common multiple. And this is a way to work out LCM and GCD. Be careful. In GCD, we have to take common prime only and take the least power, minimum power of that prime number. In LCM, we take all the prime numbers Powers must be the maximum power what the prime number attains in all of them. In all of them. That we have to choose. After that, compute the product carefully using calculator. We get the LCM as 4704 for these two numbers. If you want to find out the GCD, it is only 2 power 2, that is 4, because 2 is the only common prime number and least power of 2 is 2. 2 power 2 is, it is additional information. I write here. If I write here GCD, if you want to compute for those two numbers, as I mentioned in the previous video, that is equal to common prime number is only 2. Here we write minimum. What are the powers of 2? It is 2 and 5. So we have to take 2, minimum power is 2, that is 4. 4 is a GCD. 4 is a GCD and LCM is 4704. Always LCM value will be bigger than GCD value. Hope this video is clear to you. To find out the LCM and GCD in two separate videos I explained by using that prime factorization method. It is also called as fundamental theorem of arithmetic, how to apply it. In next video, we are going to see how to find number of divisors for a given integer, positive integer, and how to find their total. And one more video, how many positive integers are there less than that given positive integer which are prime to that, relative prime to it. So three more videos to come based on that, and later we come to know a new topic called congruences. Do share and subscribe our channel with your friends so that learning will help you a lot through these lectures. Thank you.